class, I will continue my lesson 2.2 because we left one more part, that's a superconductor. Okay, so now before I go to superconductor, you need to see it's a page, this part. They will introduce some of the components that's related with the resistance. Okay, now I draw some short notes. Let's see here. Okay, first part is a fixed resistor. Fixed resistor is every time we say about inside the circuit, we draw this diagram. This one symbol. This one is a fixed resistor. I think before that you learned during your KH, Kemaran Video class, that one is a resistor. Okay, the body for the resistor, they got different color. They got different color, that means you need to count the color. After that, you know inside this one resistor, there's how many resistors. Okay, so I show you the demo diagram. The diagram also inside here. Then I show you the color one. Okay, can you see that? The one got color one, the one is a resistor. Okay, now we're going to see actually what's the function for this one resistor. That's a common material they use as a fixed resistor. That means inside the resistor is a fixed one. If you buy there's a 5 ohm, that means that every time is a 5 ohm. They cannot changes. Okay, after that, normally inside is what? They fix with the resistor they use for the alloy, such as a nichrome and constantan. Inside the material we got alloy, constantan, or you say there's a nichrome. That one is a fixed resistor. Okay, let's see the following. The following we call it rheostat. Okay, rheostat before the last lesson I can show before the diagram. Okay, rheostat is one of the resistor also, but this one resistor we can control. That means you can control the resistance. This one is a fixed, but this one you can control. You want how many, then you just control. Okay, let's see the symbol. The symbol almost the same. You can use this one, you can use this part, but you need to add one more arrow. One arrow up means they got changes. That means the instrument you can control what is the resistance. Okay, follow the notes. Here I'm going to explain what's the function. Okay, this has a coil resistance. There are wire turning with the wire. Okay, after that the sliding contact can be moved to any position along the coil. The wire coil won't. Okay, the galong wire. So that means now you can adjust. You adjust until you touch how many wire. So that means the resistance also changes with the wire. When the length of the wire increase, resistance also increase. So that means they're using the wire, length of the wire to control the resistance. Okay, so from here they say this changes the length of the wire. As a result, they changes about the resistance. Okay, let's see the diagram. What is a rheostat? Okay, you see the rheostat. Now we go to the next one. That's a C potentiometer. Okay, potentiometer, they just like the voltage divider. They can divide the voltage, they can make the voltage become high and also control the voltage become low. Okay, you can see the diagram there. The diagram same like the adjustment for the volume. Okay, you want the volume become high, then you turn. When you just turn, okay, then they produce the voltage should be high. Or you turn become low, the voltage become low. So an example for this one, we're using for the brightness of the light. Okay, brightness of the light we can control. Okay, you want more brighter, then you want the less one. So you control by using potentiometer. Let's see the symbol. Symbol almost same like the resistor. You see here, they just add one more of the arrow at the top. So this one we call potentiometer. Okay, potentiometer, they control the length of wire. Also control the length of the wire. After that, they control resistance. Then they control the voltage. So this one is one of the potentiometer. Okay, you can refer the diagram I show you. Okay, next we go to the D. D is a thermistor. So this one is a thermistor. You see the symbol almost same like the resistor. Also same. Okay, but you add one more up, then flat. This one is a thermistor. Thermistor, what's the function? The function is a resistance changes. Also resistance can be changed, but due to what? Temperature. Okay, controlled by the temperature. If the temperature become high and low, then the resistance will be changes for the thermistor. So normally when we use it for the silent alarm. So smoke alarm. When they find in the room, temperature become high, that means fire drill. Okay, example for a fire drill, got fire, temperature high already, so the automatic alarm they will trigger. So they're using thermistor to detect the temperature. So from here they explain for you, a thermistor is a resistor. Okay, whose the resistance they change with the temperature, it decreases in the resistance as the temperature rises. So when the temperature become increasing, this one, the resistance will become low. Okay, when the resistance become low, what happens for the current? Current will up. When the current up, so that means they go to trigger the alarm. So the alarm now will be start, then everybody know that one is a high temperature. Okay, so now I show you what is a thermistor. They just like one of the flag. Okay, sometimes it's a rectangle, sometimes it's a circle. That one is thermistor, component thermistor. Okay, we're going to see the last one. Last one is the LDR, light dependent resistor. So you're going to see here the symbol for the LDR. Almost same like the resistor, but they add one of the circle, after that they got arrow. So this one resistor also depend on the temperature. The resistance can be changed, but depends on the, okay, sorry, not temperature, depends on the brightness. So when they detect the light and don't have the light, that means the resistance of the LDR will be changes. So this one is one of the resistor also. So from here they got explain for you. LDR, the changes depends on the brightness of the light falling on it. Brightness of the light on it, that increase the resistance. They increase when the brighter increase, they finally the resistance becomes decreases. So this one where we apply. We apply for the lamp through the root. Whole root they got lamp, is it? Okay, after that the lamp they will switch on for the certain time or certain brightness, we don't know. So maybe you just pass through the road, that's around the morning 7 o'clock. So that they just detect surrounding the brightness increase. So they find it, okay, now it's a morning. So automatic, all the lamp, whole road, they will off together. So they want using the LDR to detect the brightness of the light. Then after that, they will off or they will on, depend the situation. So from here, they're using the LDR to control the resistance. So this one is the last one for the component related with the resistance of the resistor. Okay, so I show you the diagram about the LDR. They just want more of the component. The head is a black color. Okay, now we go to the last part. That's called superconductor. You see what is a superconductor? Superconductor is a material whose resistance becomes zero. The resistance will make it until zero. So from here they say when the temperature drop to the certain value, we call critical temperature. Means what? Normally the resistance cannot become zero, is it? But this one superconductor, they can achieve almost become the zero. So we're using the formula V equal IR. Okay, V equal IR. So you find it when the resistance almost become the zero, then your voltage you want to change this. You find what happens for the current. Current must be the highest one. So for this one situation, if we're using superconductor, we find it the current produced from the certain circuit or certain situation, the current must be too high. When the current produced is too high, means the whole thing, whole circuit must be efficient. So this one situation is why we're using the superconductor. But not every material that can actually become the superconductor. You must have the certain temperature. So from here, refer the graph. This one is a resistance versus temperature. Remember before that we learned temperature increase, resistance increase. That one is the metal. Okay, metal is temperature high, resistance also high. But you see this part, superconductor, they are same like the metal. But when they achieve superconductor, you find it certain temperature, the resistance drop until becomes zero. So this one temperature we call critical temperature. Okay, for many situations we using critical. Example, they got critical angle. Before that we learn. What situation we call critical angle? When they achieve 90 degrees. So what situation will become critical temperature? When the superconductor achieve. They achieve until the resistance becomes zero. So we call it, this one is a critical temperature. So from here we're going to see What's the advantages for the superconductor? Okay, first one, this enables the superconductor to maintain the current with no need to apply the voltage of the temperature. So that means you no need to apply more voltage. Okay, then the resistance, when they achieve superconductor, they become almost zero. So the current must be the highest one. Okay, number two, able to sustain the large current. More current can be produced. Number three, smaller power loss during transmission when they transmit the current through the long wire. Okay, if the voltage is become standard, we know it never changes the voltage, the resistance they become lower. So that means the current pass through the whole wire, they do not lose. No need to overcome the resistance. And the last one, power loss decreases, energy loss also decreases. So that means the whole system you can reduce the energy loss, reduce the signal loss. This whole thing we say high efficiency. They can produce a high efficiency of the output. Okay, then we're going to see some example here. Okay, so let me clean the board first. Okay, we see some example for the superconductor for certain metal. So from here they say about aluminium. So aluminium, you want to achieve superconductor, the critical temperature must be 1.2 Kelvin. We're going to see 1.2 Kelvin actually is what is that? Okay, before that 0 degrees Celsius is 273 Kelvin. Okay, agree? Okay, after that we go and change this. Now 0 Kelvin. Okay, degrees Celsius must become negative 273 degrees Celsius. So this one is an info we know it. Now your Kelvin is 1.2. So now I want to convert become degrees Celsius. Mean this one you need to minus your 1.2. So your answer is negative 265.8 degrees Celsius. So for the aluminium, you want it to become the superconductor, you need to make it the temperature of the aluminium drop until negative 265.5 degrees Celsius. So this one we achieve superconductor. So not simply we want to make the material become superconductor. You must have certain temperature. Okay, so from here I can show you a little bit. That one is a video clip about the superconductor. You can see, then you can see what happened for the train. The train can be moved. Okay. Okay, finish. Then I also will show one of the small about the superconductor you can lift up above the metal, above the magnet. Also they can move without anything, but the center is empty. You still can see a while for the video clip. Okay, I show now. You need to see is it. I think that's not enough for you to see the whole system, whole process, whole video. So what I need to do, I already shared with you some of the website. Okay, during your note they got, okay, I also show you by the diagram. So I show now. Then you just copy. Then after that you can online and search what is that. If you cannot search, you also can just type superconductor in the YouTube. After that you can see whole process. Got so many video clip about the superconductor. Okay. Yeah, this is the website I show you. So you can see it. You can copy it. After that you can type on in the searching for the Google. After that you can search from the YouTube. You can see what is that. Okay, everyone finished. This one is a 2.2. The last part is a superconductor. Then all the exercise tutorial answer I already upload to the Telegram. I show you already. And the structure question also here. So you can refer to the Telegram. Okay, so the 2.2 lesson should be finished. So hopefully you understand what is the lesson 2.2. The coming soon should be 2.3. Okay, thank you for your watching. Thank you very much. Have a nice day.